Hello, ladies and gentlemen, and welcome back. Root Beer here, looking at question 3 on the MMC contest from 2017. Okay, so question 3, just like 1 and 2, is a two-parter. Let's dive in and take a look at 3A. The sides of quadrilateral ABCD are 4, 7, 20, and 11, just as we have shown. Given that AC, so we got a diagonal here, is an integer, find its value. Ooh, okay. So let's draw a picture, but a picture that includes AC. Okay, they bothered to single this out. I guess it goes down from there. So we got A, B, C, D. It was a 4, a 20, a 7, and I think this was 11. And let's add in our good buddy AC. All right. So, yep, 4, 7, 11, and 20. All right. Now, what can I do with AC? AC has got to be an integer. Okay, but I'm not given a whole lot else, and I don't know anything about angles in here, things like that. I mean, I suppose since A, D, and C forms a triangle, and A, B, and C forms a triangle, we might be able to start approaching some angles or something like that. But as soon as we make that triangle connection, suddenly we remember the triangle inequality. Or, I mean, I say we remember, I certainly remember it. If you've got a triangle and C is the longer of the sides, A plus B is greater than C. Okay. So what does this tell us? Well, it tells us things like AC must be less than AD plus DC, but I know both of those values. 7 plus 11. Okay. I mean, there are other things that we can see from here, but AC is definitely less than 18. Okay. And now we can do the same sort of thing and say AC must be less than AB plus BC, but that's just going to be 4 plus 20. 24. AC is less than 24. Yeah, I knew that because it's less than 18. But we don't just have this in it. AC doesn't have to be the C length here. It could be one of the A's or B's. And so with respect to that, we know BC must be less than AC plus AB. But that tells me 20 is less than AC. No idea why I wrote 2A there. Is less than AC plus 4. And if I rearrange that, 16 is less than AC. So 16 is less than AC is less than 18, but AC is an integer. AC is going to have to be 17. Okay? And it all came about by using the triangle inequality. Okay. So that's 3A. Let's take a look at 3B now. Positive integers A, B, C, and D are added 3 at a time. Okay. The sums are 93, 96, 105, and 114. What is the largest? What is the value of the largest of A, B, C, and D? Okay. Well, let's say D is the largest. Okay, and we do have to justify things, so let's assume or suppose or without loss of generality, A less than B less than C less than D. Then because we're adding them 3 at a time, I can say A plus B plus C has got to be the lowest of the numbers, which is 93. Why? Well, if A plus B plus D were 93, for example, A plus B plus C is less than A plus B plus D, because C is less than D. But A plus B plus C has got to be one of these other values, and they're all greater than 93. But, you know, so this is a contradiction. This is impossible. So that tells me a plus b plus c is 93. Okay? So I'm going to use that fact in a moment. Now, we could probably, I mean, b plus c plus d has got to be the biggest of the values, so we could keep going on like this. But really, I only need the smallest values. For example, I don't know if this is going to be 95 or if a plus c plus d is 95. I've got no idea. Actually, no. I guess we do, because a plus c plus d has got to be greater than a plus b plus d. So yeah, 105, and I think the other one was 114. So we could make these connections, but that doesn't really get us any closer to, yes, it was 114. It doesn't actually get us closer to the value of d, but there's a nice old trick with these sorts of questions. When we have sort of symmetric expressions, you know, these are all sums, and every single possible sum of 3 of them is here. We can add them all up, and we'll get 3 A's, 3 B's, 3 C's, and 3 D's. And then on this side, we'll get 93 plus 95, and we've got them all lined up, so we can just add them really quickly. 3 plus 5 is 8, plus another 5 is 13, plus another 4 is 17, 7, carry the 1, so 19, that's 10, plus another 10 is 20, plus an 11 is 31, plus a 9 is 40, so that's 407. That's not good. Did I miss add? 10, 20, 30, no, it should be 40, but 407 isn't a multiple of 3. So I'm unhappy. But now I can figure out a plus b plus c plus d. Did they say integers? I feel like they said integers. Yeah, positive integers, so something's gone wrong. 17, carry the 1. 10, another 10 is 20. Oh, it's not. It's a 6 here. It's a 6 here. I was thinking it might be the 105 is wrong, but so that makes it 18. All right, that's fine. Now divide by that. 39 gives us 13, and then there's 1 left over, 18. So 136 is the sum of all of these. And now if I just want D, I subtract. And I know a plus b plus c has got to be 93. So that leaves me with D, and then we can subtract 3 and 4. D is 43. Okay, we can do the same sort of thing, subtract b plus c plus d, and just really quickly on the side, we can get things like a is going to be 22. And knowing those two, we could then get a plus b plus d. Or we could, again, subtract 96 from here, and get c is 40. Okay? Or you could say the difference in these two is just d minus c. That's another way to see it, and so it's a difference of 3. And the difference here is going to be 9, so b is 31, and the difference here is 9, so a is going to be 22. These are all things that we could be doing. But we can get them all out if we needed to. Now we don't. We just need d is 43, but if we work out a, b, and c, we can do the all-important check at the end of the contest if we've got time. Check. Does a plus b plus c actually add up to 93? Yes, it does. Does b plus c plus d actually add up to 114? Yes, it does. 1 plus 3 is 4, and then 3, 4, and 4 gives me the 11. Okay? So these are nice little extra checks that we can do. Okay? So D is 43, and that was it, wasn't it? That was 3B, yeah. So 3B, and in the next video, we're going to take a look at question number 4. I will see you guys for that video next time.